Hello students, this is about Unit 2 Solution. Solution is a homogeneous mixture of two or more substances in which the components are uniformly distributed into each other. The substances which make the solution are called components. Most of the solutions are binary, that means consist of two components out of which one is solute and other is solvent. Ternary solution consists of three components. Solubility. Maximum amount of solute that can be dissolved in 100 gram of solvent at fixed temperature to make saturated solution is known as solubility. Solid solutions are of two types. First type is substitutional solid solution. For example, brass, where components have almost similar size. Second is interstitial solid solution. For example, steel. Smaller components occupies the interstitial voids. Now let us study about expression of concentration of solution. The first way is mass percentage. It is amount of solute present in 100 gram of solution. Formula is given here that you can check. Another way of expression of concentration is mole fraction. It is the ratio of number of moles of one component to the total number of moles of all components. It is expressed as X. For two component system made of A and B, that means binary, XA can be presented as Na upon Na plus Nb, and XB can be presented as Nb upon Na plus Nb. And students always remember that sum of all the components is 1, which can be written XA plus XB is equals to 1. Now another way of expression of concentration of solution is molarity. It is number of moles of solute in per liter of solution. Molarity decreases with increase in temperature as volume of solution increases with temperature. Now and fourth one is molality. It is number of moles of solute in per kg of solvent. And remember children that on molality there is no effect of change of temperature, that is mass to mass ratio. Another concentration unit is parts per million or ppm. It is concentration of very dilute solution and it is expressed in ppm. Now let us study Vapour pressure. Vapour pressure is defined as the pressure exerted by the vapor of liquid over the liquid in equilibrium with liquid at constant temperature. Vapor pressure of liquid depends upon nature of liquid and temperature. And to explain the quantitative relation, we have the Raoult's law. First point, for the solution containing non-volatile solute, the vapor pressure of the solution is directly proportional to the mole fraction of solvent at particular temperature. It can be written as Pa directly proportional to XA, or can be given as Pa is equals to P0A into XA, where P0A is constant. Second point, for the solution consisting of two miscible and volatile liquids, the partial vapor pressure of each component is directly proportional to its own mole fraction in the solution at constant temperature. It can be given as Pa equals to P0A into XA and Pb is equals to P0B into XB, where Pa and Pb are the partial vapor pressure of the two components in binary mixture, and XA and XB are the mole fraction of those two components. Total vapor pressure is equal to sum of partial pressure. We can write Pt is equals to Pa plus Pb. Now, ideal solution. The solution which obeys Raoult's law under all conditions of temperature and concentration, and during the preparation of which there is no change in enthalpy and volume on mixing the component. The conditions are: it must follow Raoult's law. That means Pa is equals to P0A into XA and Pb is equals to P0B multiply XB, where del H mixing is equals to 0, means enthalpy of mixing will be 0. Same, volume of mixing must be 0. Another condition is, this is only possible if interaction between AB is same as AA and interaction between BB. Some examples of ideal solutions are benzene and toluene. Second one, chlorobenzene and bromobenzene. Remember, very dilute solutions exhibit ideal behavior to greater extent. This is the plot of vapor pressure and mole fraction of an ideal solution at constant temperature, where on y-axis vapor pressure is considered and on x-axis mole fraction is taken. Remember students, here x1 and x2 are the mole fraction of solvent and solute for a binary mixture, where P total you have studied in previous slides is always equals to partial vapor pressure of the two components, that is Pa plus P2. Now the next is non-ideal solution. When we say non-ideal solution, it means the solution which is not going to obey Raoult's law. Here it is given in Raoult's law quantitative expression that Pa is not equals to P0A into XA and Pb is not equals to P0B into XB. As well, the enthalpy of mixing and enthalpy volume of mixing are not equals to 0. It means it may change when the two components mixed into each other. For non-ideal solution, the AB interaction is different from AA and BB interactions. For solution showing positive deviation from Raoult's law can be given as when Pa and Pb are greater than their mole fractions and the constant, that is P0A and the P0B. One more thing, that the enthalpy of mixing and the volume of mixing will be positive. It is due to the interaction between AB is weaker than interaction between AA and BB. For example, alcohol and water is the mixture which shows positive deviation from Raoult's law. Second one, for the solution which shows negative deviation. And for negative deviation, I think all of you can now understand that PA and PB should be or will be lesser than the product of constant and its mole fraction. Whereas the enthalpy of mixing and volume of mixing will be negative, means less than the original one. It is due to the interaction between AB is stronger than the interaction between AA and BB. Remember the examples: chloroform and acetone, and another example is hydrochloric acid in water. Both shows negative deviation from Raoult's law. Here is the plot which shows positive deviation and negative deviation from Raoult's law. You can say the vapor pressure of two component systems as a function of composition. A solution that shows positive deviation from Raoult's law, and B a solution which shows negative deviation from Raoult's law. Now the next is, what is azeotrope? The mixture of liquids at particular composition which has constant boiling point, which behaves like a pure liquid and cannot be separated by simple distillation, is known as azeotrope. Azeotropes are of two types. The first one is minimum boiling azeotrope. It is for the mixture which shows positive deviation from Raoult's law, for example alcohol and water. Second one is maximum boiling azeotrope. The mixture which shows negative deviation from Raoult's law, and the example is acetone and chloroform. Now let us move to the next topic, and this is qualitative property. All those properties which depend on the number of solute particles irrespective of their nature relative to the total number of particles present in the solution. Such properties are called colligative properties. Colligative is from the Latin word where co means together and ligare means to bind. These are relative lowering in vapor pressure of the solvent. Second, depression of freezing point of the solvent. And the third one is elevation of boiling point of the solvent and osmotic pressure of the solution. The first one, quantitative expression can be given for relative lowering in vapor pressure, and it is written as P naught A minus PA upon P naught A, that is equals to XB, which is mole fraction of solute. This relation always used for the determination of molar mass of the solute, and quantitative expression is given here. Next is elevation in boiling temperature. The quantitative relation is del Tb is equals to Kb multiply molality, where del Tb, which is change in boiling temperature, can be given as Tb minus T naught B, where Kb is the molar elevation constant and small m is molality. And this can be modified for the calculation of molar mass of the solute, which is given here in terms of mb. Next one is depression in freezing point. It is represented as change in Tf is equals to Kf into molality, where Kf is the molar depression constant. Now come to the osmotic pressure. When two solutions of different concentrations are separated by semi-permeable membrane, there is spontaneous flow of solvent from dilute solution to concentrated solution. This phenomenon is osmosis. The minimal external pressure applied on concentrated solution to stop the flow of solvent is known as osmotic pressure. It is denoted by pi and is expressed as pi is equals to N by V RT or CRT, where C is the molar concentration, N is the number of moles, V is the volume of solution, R is constant temperature in Kelvin. Now, isotonic solutions. These are the solutions which have same osmotic pressure. Next, solution having comparatively higher osmotic pressure are hypotonic. The solution which have lower osmotic pressure are called hypotonic. Blood fluid possesses osmotic pressure equal to 0.9% solution of NaCl. Abnormal molar masses can be given as molar mass of solute in solution either less or more than the normal molar mass is called abnormal molar mass. Such abnormality in the calculation of molar mass is overcome by want of factor, which gives as I is equals to observed qualitative property upon normal qualitative property. Here, degree of association and degree of dissociation is given in the form of quantitative expression that you can see. And want of factor I is also given in terms of molar masses. Thank you, students.